Hello, good evening. My name is Gabriel Medina. I'm a student of telecommunications engineering, and here I'm gonna show my ID. And for today, what we're gonna do is I'm gonna explain the assignment for task one, which is electromagnetic waves in an open media. And what we were asked for was the following. So we have to answer some questions, right? So so the first question is, what is an open propagation medium, right? And an open propagation medium is a medium that we don't have any resistance to the flow of the signal. I mean, to the signal flow per se, or the wave flow, right? What does that mean? That means that we don't have any change in the direction of the wave, and we don't have any interference in the wave itself, right? So that's what it is. So the second thing is, what is the loss tangent? So the loss tangent means that we are gonna calculate or measure how much loss we have in the medium, right? And we also define if this particular medium is a great conductor or not, right? For the third question, we have a reference of how we classify the mediums based on the value of the loss tangent, right? So I mean, based on that, we have this particular table, and we can have an example. For example, when we have a loss tangent of 0, we consider that particular media as a perfect dielectric, and we I mean that's a non-dissipative media as well. So there's the other type of propagation in here, and their examples, right? So now in the question 4, they are gonna ask you or ask us, what are the propagation parameters? I mean, the wave propagation parameters, and here we have them, right? So we have 3 of them, which is propagation constant, attenuation, and phase, right? So after that, we are gonna do an exercise, which is we're gonna choose a media. In my case, I'm gonna choose a vacuum. In this particular medium, I need to calculate the loss factor or the loss tangent with this particular formula, and I mean also using my ID, or the last 3 numbers of my ID, and I need to calculate the loss factor. So in this particular case, since the conductivity in the vacuum is 0, the loss tangent will be 0. Here we have the formulas and also GeoGebra that we're gonna use for that, and here we have the result of that, right? So based on the loss tangent being 0, we can define that particular media as a perfect dielectric, and also as a due to the its non-dissipative properties, right? So, and based on that, on that classification, we need to obtain the wave parameters, right? So in this particular case, this is a perfect dielectric. We're gonna use a non-dissipative parameters, right? And we're gonna use the formulas to obtain that particular parameters, right? So in this particular case, here are the formulas that we're gonna use, right? And here are the results of those formulas, right? So then, when we have those things or those parameters, we're gonna calculate the characteristics of the wave, right? Or the propagation of the characteristics of the wave propagation. That's the correct word, right? So in this particular case, those characteristics are the propagation speed, the wavelength, and the penetration depth, right? So here we have them. Here are the formulas that we have, and one interesting fact that we can see from that is that the propagation depth goes to infinity, and I think this is because since in the vacuum there's no the loss factor in the vacuum is 0. The vacuum is not giving or providing any resistance to the wave, right? And that's good because there are a lot of use cases for that. One of the most common ones is the use of satellite communication. So when we're gonna transfer wavelengths or electromagnetic waves through the space or through all the world, we use the vacuum as a media, right? And we can see how effective those communications are, right? So that's it for today. I hope this has been informative for you, and I would like to thank you for viewing.